In this video, we are going to cover short questions and their solutions. Question number 1, evaluate the limit t tends to 0. So, in each component, we have to put t is equal to 0, and if it is not there in finite by infinite form or 0 by 0 form, then we can put t is equal to 0 directly. So we'll get this step. If it is in infinite by infinite form or 0 by 0 form, then we have to use L'Hospital rule. So here it is equal to 1 I bar plus 0 j bar plus 1 k bar. So the final answer is I bar plus k bar. Then question number 2, find the unit tangent vector t vector for the vector function. This vector rt is equal to t square plus 1 I bar 3 minus t j bar and t cube k bar. So just find the velocity dr by dt. So we'll get this, and then modulus of v vector vt, which is equal to this, and it is equal to root 4t square plus 1 plus 9t square. Then tangent vector you can find by vector vt by mod vector vt. Then question number 3, evaluate 4 integration 4x square ds along curve C, and along curve C, which is circle, parameterized as 2 cos t I bar plus 2 sin t j bar, and t lies between 0 and pi by 2. So here you can see the radius of circle is 2. So we'll take x equal to cos t. If we compare this vector rt with xi bar plus yj bar, so x equal to 2 cos t, and ds is equal to mod of vector rt dt. So we'll write here root x square and plus y square. The value of x and y is 2 cos t and 2 sin t. So dt. So therefore, after solving, we'll get this. And sin square t plus cos square t will take 4 common and the under root, and root 4 is equal to 2. So we'll get ds is equal to 2t. So when we put this in the formula and the value of x here, and then when we integrate, the integration will become 0. Question number 4, find del cross f bar, which is equal to curl f, and the vector f is given 6 I bar 2y minus y square j bar plus 6j minus x cube. So curl of f, you have to write first row, in the first row ijk, in the second row del by del x, del by del y, and del by del z, and then you have to write the component, all the component. Maybe it may be pqr or it may be mnp something. Then just solve this determinant. So solving this determinant, you will get this step, and finally after simplifying, we will get 3x square j bar plus 2k bar. Question number 5, find the gradient vector field of the function f of x comma y comma z xy plus yz plus xz. So gradient of f is equal to del f by del x I bar plus del f by del y j bar plus del f by del z k bar, or you can write gradient f in the coordinate form also. So you'll get this. Question number 6, state Stoke theorem. Stoke theorem states that for a vector field f and surface S with boundary C, curl f dot and vector d sigma along surface S is equal to integration f dot dr along closed curve C. Question number 7, if S is the closed surface enclosing a volume V and f vector is equal to xi plus 2yj plus 3zk, then evaluate integration f dot and ds along surface C. So by divergence theorem, double integration f dot n ds is equal to volume integral of divergence f dv. So divergence of f you have to find in this way, del x by del x, here this component, and del of 2y by del y, and del of 3z by del z. So it is equal to 1 plus 2 plus 3, which is equal to 6, and put these value in this integration. So double integration f dot and ds is equal to putting the value of divergence f here. So it is equal to 6. 6 you can write outside of integral, and this is the volume of this is not given actually, it's not specified in the question, so we'll write only v here. So 6v is the final answer. Thank you. Link of PPT is given in the description.